How did RC transmitters evolve from bang-bang to proportional? Imagine controlling a model car or airplane with just a simple switch. That was how early radio control transmitters worked. They used what is called bang-bang control. This means they could only send signals that were fully on or fully off. So, if you wanted to turn a steering servo left or right, the transmitter would just send a full signal or no signal at all. This made the model move in jerky, quick steps. It was simple but not very smooth or precise. Back in the 1930s and 1940s, these systems used vacuum tubes and relays. They would switch the motor or control surface fully on or off. This was okay for basic movements but limited in how well it could control things. If you wanted a gentle turn or a slow throttle, it was hard to do with just on or off signals. The control was very binary, meaning only two options. Then, in the late 1950s, things started to change. Innovators like the Good brothers developed what is called pulse proportional systems. Instead of just on or off, these systems used pulse width modulation. This means they sent signals where the length of the pulse varied. Longer pulses meant more control, shorter pulses meant less. The receiver could interpret these pulses and move the servo to any position within its range. This was a big step because it allowed for smooth, continuous control instead of jerky movements. At the same time, tuned reed systems came into play. These used metal reeds that resonated at certain frequencies. When activated, they could control relays and handle multiple channels. But they still had limitations in providing smooth, proportional control. They were better than on-off systems but not as refined as later systems. In the 1960s, transistor technology arrived. Transistors replaced bulky vacuum tubes and mechanical relays. This made transmitters and receivers smaller, more reliable, and easier to produce. With transistors, engineers could design circuits that handled pulse width modulation more efficiently. This led to the first commercial proportional systems, like the Space Control in 1960. It used pulse width modulation to give smooth control of servos, making models respond more like real vehicles. By the 1970s, digital electronics became common. Integrated circuits allowed for even better control, multiple channels, and less interference. Digital proportional systems could handle complex commands and deliver very precise movements. This is what we see today in modern remote control toys, drones, and cars. All these steps helped models become more realistic and fun to control. Early systems could only do simple, jerky movements. Now, thanks to electronic advances, we can steer smoothly, accelerate gradually, and perform complex maneuvers. The evolution from bang-bang to proportional control was driven by the desire for better, more natural operation. It's a story of technological progress that transformed simple radio control into the sophisticated systems we enjoy today.